monitoring and control system by using AT89C52 microcontroller. The system automatically monitors temperature, humidity, soil moisturizer, and light intensity. So, and also control devices like a water pump, ventilation fan, and the artificial intelligent lighting through relays. I will now explain the schematic and working of the entire hardware. So coming to the microcontroller section, which is AT89C52, at the center of the circuit we will find we have the AT89C52. So it is responsible for reading sensor values, processing the data, and switching the output devices. The control oscillator X1, which is like this one, the frequency is 11.0592 megahertz, and the capacitor C1 and C2 provides accurate clock timing for the MCU. So a resist circuit R1 and C3 ensures the controller starts properly every time the system powers on. So coming to the ADC block, we have used an ADC0808. Since most sensors give analog output, we use ADC0808, an 8-channel analog to digital converter. The addresses line from the microcontroller section select the sensor channels and convert digital value is sent back to MCU. Capacitors filter noise and references pin define ADC accuracy. So the sensors we are using in this circuit is temperature sensor, light sensor, light sensor, and humidity sensor. So light sensor LDR is used with a variable resistor forming a voltage divider. As light intensity changes, resistance changes, creating a variable voltage sent to ADC IN1. So soil moisturizer, which is similar to the soil moisturizer module output variable voltage depends on soil wetness also fed into the ADC. These three resistors allow the system to continuously monitor greenhouse. So temperature sensor, this one is the temperature sensor, this one is the humidity sensor, this one is the LDR sensor, which is nothing but the light. So this one is the temperature sensor, which is connected to the ADC channel N0. So LCD display, which is we used 16 into 2 LCD display, is connected 4-bit mode. It shows real-time values of temperature, soil moisturizer, and light intensity. It also depends upon the pump on, fan on, light off. It gives the clear on-site monitoring for the user. So relays, drivers, and accurate sections. So the output controller section, which is relays, we are using three relays, that is RL1, RL2, and RL3, driven by an NPN transistor and protected by a flyback diode. So these allows microcontroller to safely switch 12 voltage ADC to DC loads. RL1 controls the water pump for irrigation. RL2 controls artificial light or heaters, like RL3, which is an ventilation fan. So whenever the MCU detects the sensor, the values across threshold, it activates the respective relays automatically. So coming to the communication, we used the transmitter and the receiver pins at the bottom of the schematic allows connection to GSM, Bluetooth, or RF modules. This sends the sensor data wirelessly for a remote monitoring, like it will be displayed in the phones. So coming to the power supply section, a regulative 5-volt supply power the microcontroller, LCD, and sensors using a 7805 voltage regulator. Relays typically operate 12 volts, which is provided by an external supply. So the system working is, oh man, so we have to attach the SmartX file, which we written the code in New Vision. So I attached this smart, okay, and run this. So here how the system works as a whole. Sensor continuously measures temperature, moisturizer, and light ADC. So here we observe the smart agriculture. So later it takes 5 seconds to display the temperature, soil, and light. So based on the continuous, the soil moisturizer is low, then RL1 turns on, the temperature is high, RL2 activates the fan, and the light is low, RL3 switches on the artificial that one it will take. So now we'll see clearly the output is temperature is 72.5 degrees Celsius and soil is 15% and the light is 1%. So this one is the output. So coming to my conclusion, my smart greenhouse system integrates sensors, ADC, microcontroller, logic, relay drivers and display to automate essential agriculture process. It improves the plant health, saves water and reduces manual labor. Thank you for watching my project demonstration. Thank you.